external force acting on the bike when the rider stopped pedaling. So why didn't the bike stop? Here is another activity for you to observe. If you pull out the cardboard with a jerk, the coin will drop into the tumbler. Why doesn't the coin get pulled away with the cardboard? Both the phenomena that you just observed can be explained through the law of inertia, also called Newton's first law of motion. Newton presented three laws that govern the nature of motion. These laws are derived from Galileo's ideas and experiments. Let's take a look at Galileo's experiments with inclined planes. Consider a marble resting on a plane inclined on both sides. Now, the marble is released from the left, that is, end A. The marble rolls down the slope and travels up the other slope till it reaches the same height from which it was released. In this case, the inclinations of the planes on both sides were equal. Therefore, the distance covered by the marble rolling down was the same as the distance it climbed up on the other plane. Let's see what happens if the angle of inclination of the right-hand side of the plane is gradually decreased. The marble travels a longer distance till it reaches its original height. The angle of inclination of the right-hand side of the plane has been reduced
Laboratory
to zero.
thermometers are used in laboratories
The plane
and
is
factories
horizontal.
to measure liquids
How
with a
far will
wide
the marble
temperature
travel
range.
now?
The temperature range on
It
a laboratory
travels quite a
thermometer
distance.
extends from minus 10
The marble
degrees Celsius
stops eventually
to 110
because of the
degrees
frictional
Celsius.
force opposing its motion. In practical situations, it is difficult to achieve zero
Except
unbalanced
for the
force
temperature
because
range,
of frictional
laboratory
force.
thermometers are designed just like clinical
However,
thermometers.
friction can be minimized by using a smooth marble on a smooth surface and using lubricants. If the surface of the plane
In order
is
to
completely
use a thermometer,
frictionless,
first
the
you
marble
need to
will
understand
travel forever,
its scale.
trying to reach its original height. Thus,
Consider
a marble in
any
motion
two consecutive
would keep moving
numbers
if
on the scale.
unbalanced forces or the net force on the marble
For
was zero.
instance, 37 and 36.
From this, Galileo
difference between the
deduced
two
that an
is equal
unbalanced
to
external
1.
force is required to change the motion of an object.
Next, count the number of divisions between these
Once
two
the object
numbers.
starts moving, the application of no net force
The
is
number of
required
divisions
to
here
keep it
are
in
5.
uniform motion. Consider
Divide the
the example of
difference between the
spacecraft
two consecutive
Pioneer 1,
numbers by the number of
launched
divisions
about 20
between
years
them.
ago. Deep in space, it keeps moving
The
even
result will
without
give
the
the
aid of
value
engines,
of each
because
calibration.
there is no frictional force in space to stop
This
it.
thermometer, each
The
calibration
tendency
reads a
of
value
undisturbed
of
objects
0.2
to stay at
degrees
rest
Celsius.
or to keep moving with the same velocity is called inertia. Newton's
check
first law
how
of
well
motion
you can
states
read a
that an
thermometer.
object remains in a state of rest or of uniform motion in a straight line unless compelled to change that state by an applied force. That's why the first law of motion is also known as the law of inertia.
Clinical and laboratory thermometers are used to measure temperatures of
Can you
different
think of
objects.
some real-life applications of this law?
Hence, their method of usage also differs.
Well, consider the
While
concept
using
of
a
wearing
clinical
safety
thermometer,
belts in cars.
hygiene is very important.
Why do we need these belts?
So the first step is to clean the thermometer with an antiseptic solution.
When a car is moving, we are at rest with respect to the seat, but moving along with the car with respect to the road. In the unfortunate
Hold
event
it
of a car
horizontally
crash,
and check if the
car
mercury
may
level
stop
is
suddenly.
below 35 degrees Celsius.
Even when the car
If not,
stops,
hold
our
the
body
thermometer
tends to
firmly
continue
and
in the
jerk it
same
a few
state of
times
motion
to bring the level
because of its
below
inertia.
35 degrees Celsius.
Without a seatbelt, our
Now,
bodies would either
place the
slam
thermometer
into
below the
steering
tongue for
wheel
2
at
minutes.
a high speed, or go flying through the windshield,
As
causing
the
injuries
mercury gets
from the
heated
impact.
due to the body temperature, it will rise.
Another common example you can see is the game of carrom.
Read the temperature by holding it horizontally
Attempt to
in
hit
the line of
at
sight.
the bottom of a pile of coins. With a strong
Do
hit,
you notice
the
a small
bottom coin moves
constriction
out,
or kink
while the other coins
just
in
above the
pile
bulb?
fall vertically
This
to the
constriction
table.
prevents the mercury level
This
from
is
dropping,
because of
even after
inertia
it is
of
removed
rest.
from the mouth.
Can you now use the law of inertia
A laboratory
to explain
thermometer
why
doesn't have a
the
constriction.
bike doesn't stop immediately when you apply the brakes?
Hence, the thermometer
The
should be
coin
read
over the
while
cardboard
it is still in
falls
contact
into
with the
tumbler
liquid.
when the cardboard is pulled out.
While using a laboratory thermometer, hold it upright in the liquid without tilting it.
The bike doesn't stop immediately.
Ensure that the
because
bulb
of
is
inertia
completely
of
surrounded
motion.
by the liquid, but not
However,
touching the
it
container's
stops
base.
after a while because of the opposing force of friction.
When the mercury
from
in the
road
capillary
surface.
stops rising, note the temperature.
In the absence of this frictional force, the bike would have
The
continued
Fahrenheit
running,
scale is named
rather
after its
like a
founder,
satellite.
Gabriel Fahrenheit.
Similarly,
He proposed
the coin
this
falls
scale in
into
the year
tumbler
1724.
because of inertia of rest. So far, we have considered inertia in terms of rest, or the speed of an object. But velocity refers to direction as well as speed. When a car takes a turn at a high speed, you are thrown to one side. Why does this happen? Because, owing to inertia of motion, your bodies want to continue traveling in a straight line. The engine is applying an unbalanced force to change direction. Our inertia makes us slip to the side of the seat opposite the direction of the turn. Discuss in groups the answers to these questions. The boy is able to kick and move the football easily, but not the stone. That's because the inertias of all objects differ. Heavier objects have more inertia. In other words, heavier objects offer more resistance to a change in the state of rest or motion. What would be easier to pull forward? A bicycle or a truck? Why? The bicycle is lighter and hence offers less resistance or of inertia to being made to move from a state of rest. Thus, the mass of an object can be said to be the measure of its inertia.